Right angle trigonometry, which means we're going to focus on a right triangle because a right triangle has a right angle. Right angle is 90 degrees. 90 degrees is the same as pi halves radians because pi is the same as 180, and if you divide 180 by 2 you get 90, which means you divide pi by 2 you get pi halves. Now this right triangle has three angles, and those add up to be 180 degrees. If the right angle is 90 degrees, that means these other two angles equal 90 degrees when they're added together, which means each of these are less than, or is less than 90 degrees, which means each of these are acute angles. Now we're going to call this side A and this side B. Those sides that connect or that are adjacent to the right angle are called legs, and then the side opposite the right angle, which is the long side, is called the hypotenuse. And that leads us to the Pythagorean Theorem, which says if you square the two legs, add those two results together, that's going to equal the square of the hypotenuse. And then there are some ratios with the sides that exist. A over B, A over C, B over A, B over C, C over A, and C over B. That's what we have here. Now, what's number 5 is saying that these ratios exist for any right triangle. Doesn't matter what the sides are, what the angles are. Which leads us now to the most important thing we're about to discuss, which is sine, cosine, tangent, and then cosecant, secant, and cotangent. Let's draw the right triangle down here so we can see what it is. We're going to call this A, and this side B, and this side C once again, and we're going to call this angle our theta. So when you think of sine, sine is the same as opposite over hypotenuse. So I'm going to write it as opposite over hypotenuse. So what that means is, if you look at this angle, this theta, the side opposite is the B. Hypotenuse is always the C in this case, so the sine of theta is B over C, and that's where this comes from. Well, cosine is the adjacent over the hypotenuse. So look at theta, the side that's adjacent to it that's not the hypotenuse is side A. So adjacent over the hypotenuse is A over C. Now tangent is opposite over adjacent. So here's our theta once again. The side opposite that is B, and the side adjacent to it, not the C, not the hypotenuse, is the A. So it's B over A. Now cosecant, secant, and cotangent follow along with it. Cosecant is like the reciprocal. It is the reciprocal of sine. It's hypotenuse over opposite. So if sine is B over C, then cosecant is C over B. Or if you want to look at the angle, if it's hypotenuse over the adjacent, C is the hypotenuse and A is the adjacent. These are just definitions. You need to really memorize these. Secant is the hypotenuse over adjacent. I think I may have misspoken here. Cosecant is reciprocal of sine, which is hypotenuse over opposite. I think I may have said adjacent. Hypotenuse over opposite. So it's the hypotenuse, which is C, over the opposite, which is B. C over B. Secant is the hypotenuse over adjacent. It's the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, secant is the hypotenuse over the adjacent. And so that's C over A, because A is the adjacent. And then cotangent is the adjacent over the opposite. And the adjacent is A, and the opposite is B. It's A over B, which is the reciprocal of tangent, which is B over A. And we're going to use the information to find the value of all 6 trig functions. Before we can do that, and this is our theta that we're going to look at. Before we can do that, we need to find C. And so Let's find C. We're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Now remember, A and B are the legs. It doesn't matter which one you call which. So if I call A 5 and B 12, C stays C. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. Let's see how well you remember your algebra. To find the value of C, we square root to eliminate the exponent. And it's actually plus or minus, but since we're dealing with the side of a triangle, the answer cannot be a negative. And the square root of 169 is 13. So we now have C is 13. So now we're going to find sine of theta. I touched something on my pen and it goes crazy. So we're going to find sine of theta, cosine of theta, tangent of theta. This is the abbreviation for cosecant, and SEC is the abbreviation for secant, and COT is the abbreviation for cotangent. So sine, cosine, tangent, cosecant, secant, and cotangent. And that's what these abbreviations are. So let's find these. And it's not going to take us long to do this if we know our definitions. Sine of theta is the opposite over the hypotenuse. Here's our theta, and the side opposite is 5, and the hypotenuse is the C, which is 13. We're done. Cosine is the adjacent over the hypotenuse. Here's our theta. Adjacent is 12. Hypotenuse is 13. Tangent is opposite over adjacent. Here's our theta. The opposite side is 5. The adjacent one is 12. 5 over 12. Now cosecant is the reciprocal of sine, or also known as hypotenuse over opposite, which means we're just going to take the 5 over 13 and flip it over. Secant is the same as hypotenuse over adjacent. And if you want to look at the triangle, it's 13 over the adjacent, which is 12, which is reciprocal of cosecant, or cosine, I mean. Secant is reciprocal of cosine. Cotangent is the same as adjacent over opposite. Adjacent is 12, opposite is 5, so that's 12 over 5, which once again is the reciprocal of tangent. Reciprocal. Makes your life a lot easier if you remember that. Sine and cosecant. Cosine and secant. Tangent and cotangent. Now we have some, well, this is what I've been talking about, the reciprocal identities. Sine of theta is the reciprocal of cosecant. Cosine is reciprocal of secant. Tangent is reciprocal of cotangent. And you can easily write cosecant is 1 over sine. Let's see if that's already up there somewhere. I don't think it is. And it's not. But it should be. Secant of theta is the same as 1 over cosine of theta. And we can also write cotangent theta is 1 over tangent theta. So we got these three and we got these three. They're late, you can see. And then if you haven't figured it out by now, tangent is the same as sine over cosine, and cotangent is the same as cosine over sine. Do you want to know why? I'm going to use this example to show you why. See how well you remember your algebra. Take tangent of theta, which is opposite over adjacent. Well, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. If you were to divide fractions out, these hypotenuse would cancel out, leaving opposite over adjacent, which is what tangent equals. And if that were sine, and this were cosine, when you divide them out, you get this, which happens to be tangent. So therefore, tangent is sine over cosine, and cotangent is cosine over sine, because if these are reciprocals, and so are these. Things to keep in mind. So here's what you really want to know. You want to know the fact that cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, tangent is sine over cosine, cotangent is cosine over sine. I can make this a whole lot easier, but I'll say that for another day. And if you do know sine and cosine, then you know everything, pretty much. Now let's look at this Pythagorean identity. We have sine squared plus cosine squared equals 1. Well, if you look at the Pythagorean Theorem, we have a squared plus b squared, which equals c squared. And if we divide everything by c squared, and we write this as a over c squared plus b over c squared, then c squared's cancel, leaving a 1. Well, what does a over c equal? And b over c, what does that equal? Let's go back up here. A over c is cosine, b over c is sine. So a over c is our sine theta. B over c is cosine theta. And don't forget the squares. 1. Now, this tells you that we can put the exponent on the outside, or we can put it on the trig function. That's what that means. Most times we'll put it on the trig function. Now, I'm not going to show you where these come from, because these may be homework problems that you may have to do one of these days. But it does come from, if you were to divide by sine squared or cosine squared, you'll get these two identities. And what this does, these give us another way to find trig values. So this method 1 we did with the Pythagorean Theorem, and then used our definitions. And then method number 2, we're going to use these trig identities, hopefully, including these. We're going to use these trig identities and maybe these, but these will be the main ones that we'll use. So we have sine is 1/2 and cosine is square root 3 over 2. So let's find tangent of theta. Now tangent of theta is sine over cosine. And the sine is 1/2 and cosine is square root 3 over 2. Now I don't know what y'all know, so I'm going to assume that you don't know how to do complex fractions. So I'm going to rewrite it like this. And hopefully you'll now remember to multiply by the reciprocal, which means that these 2's cancel and it leaves 1 over square root 3. Or you could have done this. You actually could have taken 1 times 2 over 2 times square root 3, or just cancel out these 2's. 1 over square root 3. Now, we don't like radicals in the denominator, so we're going to do something called rationalize the denominator, which means we're going to multiply by the denominator to itself, because what that means is we're going to get square root 3 times the square root 3, which is the square root of 9. In fact, I'm going to erase that and put in all the steps so you'll see, which is the same thing as 3. So if you take a square root times itself, you always get that number without the square root. But what you do to the bottom, you must always do the top. So it means I got to multiply 1 times square root of 3, which is the square root of 3, which means our best answer is the square root of 3 over 3. Now, I'm going to find cosecant of theta, which is the same as 1 over sine of theta. So that's 1 over, and sine of theta is 1/2. And you can do this. Let me show you a trick. I briefly mentioned it up here. I call it ooey. Ooey. Outers over inners. 1 times 2 is 2 over 1 times 1, which is 2. Or you can divide it out or use your calculator. If you're going to use your calculator, let me show you how you do that. 1 divided by parentheses 1 divided by 2. Notice the parentheses. Now let's do secant of theta, which is 1 over cosine of theta, which is 1 over square 3 over 2, which just means you're going to flip the denominator, or this whole fraction over. There's no way to think about it, just flip it over. Or write it out like this. But in either case, we don't like the radical on the bottom, so we times it by the square root of 3, top and bottom. Square root of 3 times square root of 3 is 3, and 2 square root of 3 stays 2 square root of 3. And then the last one we're going to do is cotangent of theta, which is, well, I don't have to, I can use cosine over sine if I want to. I don't even have to do that, because that's the same as 1 over tangent of theta. We've already found tangent of theta is the square root of 3 over 3. And once again, that just means that we're going to take the bottom and flip it over. That's 3 square root of 3. And we don't like that because of the radical on the bottom. So multiply it by itself. Square root of 3 times square root of 3 is 3. The top becomes 3 square root of 3. And these 3's cancel out, leaving the square root of 3. Make sure you remember how to rationalize the denominator. Don't forget that. My MATLAB system, or whatever system you're using, may count it, may not count it. So whenever in doubt, rationalize. Now we got another example. We're going to use some more identities. We're going to use cosecant squared of pi fifths minus cotangent squared of pi fifths. So let's just use what we know. We know that cosecant is same as 1 over sine, and cotangent's 1 over tangent, and cotangent's also the same as cosine over sine. So let's see what we can use. Cosecant squared. So I'm actually going to, I'm going to write it like this. So that's same as 1 over sine squared of pi fifths. Cotangent, since I have a sine squared on the bottom here, I'm going to use the cosine over sine identity. So that's cosine, since it's squared, it's cosine squared pi fifths over sine squared pi fifths. Now what that means is I have like denominator, so I keep the sine squared pi fifths on the bottom, and on the top I have 1 minus cosine squared pi fifths. Do you know what 1 minus cosine squared is? Well, do you remember this identity? Sine squared theta plus cosine squared theta equals 1, which is the most basic one that you really have to know. Watch what happens. See, I have 1 minus cosine squared. Now theta is any angle. So I have 1 minus cosine squared down here. So how can I get 1 minus cosine squared up here? If I subtract it off from both sides. Which means sine squared is equal to 1 minus cosine squared. Which means this 1 minus cosine squared pi fifths is the same as sine squared pi fifths, which happens to be the same thing as the bottom, which means that anything divided by itself is 1. Kind of neat, isn't it? It's fun. complementary angle theorem from an algebra class or geometry class. Hopefully you remember that two angles are complementary if they equal 90 degrees. And remember, that's the same thing as pi halves radians. So if you take two angles and add them together, they equal 90, or pi halves. And if you look at this triangle, we're using angle A and then you have angle B, and they may or may not be the same. If we use the trig identities, here's some things that you're going to recognize. Sine of A is the opposite over the hypotenuse, so it's A over C. Now if you look at B, A is the adjacent and C is the hypotenuse. So what that's saying is that cosine of B is A over C. So that saying is that sine of A is equal to cosine B, which means that the sine of an angle is equal to the cosine of its complement, because A and B are complementary angles. Because this angle is 90, that means that A plus B must be equal to 90 degrees. We can also say A plus B is equal to pi halves radians, because these two angles are complementary. So we could even do this. If we say that angle A is theta, so we now have theta plus B equals pi halves. That means that B is equal to pi halves. I'm going to subtract out off theta. So that's pi halves minus theta. So B is going to be pi halves minus theta. So if A is theta, if one angle is theta, the other angle is pi halves or 90 minus theta, because that is the same as 90 degrees. And if you add these two together you get 90 degrees or pi halves. These two angles, that is. So what that means is, if you take the sine of one angle is equal to the cosine of its complement. Did you catch that? That's what I'm saying here. The sine of A is equal to cosine of B. Sine of A is equal to cosine of B. The cosine of A is equal to the sine of B. The tangent of A is equal to the cotangent of B. And cosecant of A is equal to the secant of B. Cofunctions. Let's see. Hopefully you can understand that. Let's see. So, first definition I want to point out is sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. And the cofunctions of elementary angles are equal. That's what I was trying to get at. So the sine of A is equal to the cosine of B. The secant of A is equal to the cosecant of B. And the tangent of A is equal to the cotangent of B. In fact, I could probably write those down for you. I'm going to leave off the theta. A and B are complementary angles. Sine of A is equal to cosine of B. The secant of A is equal to the cosecant of B. And then the tangent of A is equal to the cotangent of B. A and B are complementary angles. Have to be. Here we go. We have an example. Sine of 80 degrees times the cosecant of 80 degrees. Well, the sine of 80 degrees, well, first off, we need to look at the fact that cosecant is the same as 1 over sine. see that. So this example probably should have been up here, but that's fine. So sine of 80 times 1 over sine of 80 is the same as sine of 80 divided by sine of 80, which is equal to 1. Because when you multiply fractions, you multiply straight across. But this example is one we need to talk about. First off, when you see this example, notice that 38 degrees plus 52 degrees is equal to 90 degrees, which means that 38 and 52 are complementary. They're complements of one another, which means the sine of 38, and I'll show you what I'm talking about. If I call that theta, well, I'm actually not going to call it theta. I'm going to call it 38 degrees. I'm going to call this one 52. I'm going to call that angle A and that angle B, or A and B. Yeah, well, I don't really need that too much, do I? I just need A, B, and C. So what that means is sine of 38 is B over C. And if you notice, B over C, see this B over C? Take a good look at it. What do you notice with respect to 52? Well, B is the adjacent of 52. And C is the hypotenuse. Adjacent over hypotenuse is the same as cosine. So the cosine of 52 is also B over C, which means the sine of 38 is equal to the cosine of 52 degrees. And I leave the other 52 degrees as it is, and anything subtracted from itself is 0. So here's what I was trying to explain with this example, with these, is the complement of 38 is 52, which means the sine of 38 is equal to the cofunction of its complement, and its cofunction is cosine, and the complement of 38 is 52. That little triangle example can actually help you out. Now look at this one. This is a notation question, so you want to be aware of this. Tangent of theta is 1/2. We want to find cotangent of pi halves minus theta. Remember, pi halves is the same as 90 degrees. And if you remember my example before, I had theta was up here, and then this one is its complement, which is the same as 90 degrees or pi halves minus theta. So what that means is that cotangent of its complement is equal to pi halves minus theta, I should say, is equal to the tangent of its complement. Well, what's the complement of pi halves minus theta? Well, that's just theta. So what that means is that the cotangent of pi halves minus theta is equal to tangent of 1/2, or tangent of theta, which is equal to 1/2. The cofunctions of complements are the same, have the same value. Now let's see if we can throw in the side and see what happens. So the tangent of theta is 1/2. Well, that means that the cotangent of its complement, or this angle, is also going to be 1/2, because cotangent is adjacent over hypotenuse and tangent or adjacent over opposite. See, tangent of theta is opposite over the adjacent, 1/2. The cotangent of its complement, in this case, which is pi halves minus theta. Cotangent is adjacent over opposite, which is also 1 over 2. So there's two ways of doing it: triangle or identities.